Hi, let's take a look at question number 2. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If bt is the weight of the bird in grams at time t days after its first weight, then dB dt equal to 1/5 times the parenthesis 100 minus b. Let y equal b at t be the solution to the differential equation above with initial condition b is 0 equal 20. So we know b at t equal to the weight of bird. At t is a function of time because at time change the weight change. Then b prime t equal to the rate of change of the weight. So now we are going to take a look at part A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So is the bird gaining weight faster? It means, okay, is BHT increasing faster when weight is 40, b equal 40, or b equal to 70. So if you want to find if BAT increasing or decreasing, so we had to use the b prime t. Okay, so one more time. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So basically, they ask you, is the BAT increasing faster when b equal to 40 or b equals 70? In order to find a function is increasing, we have to use the derivative b prime. So over here, b prime is dB dt equal to 1/5 times the 100 minus b. So now we finish analyzing the question, so we're going to show our answer. Okay, so when b equal to 40, so we're going to calculate. So we compare, and definitely 60/5 bigger than 30/5. So now our conclusion is the bird is gaining weight faster at weight of 40. So we finished part A. Let's take a look at part B. Part B. Find the second derivative in term of B and use the second derivative to explain why the graph B cannot resemble the fine graph. So there are two parts. First part is to find the second derivative. And then the second part is to use the second derivative to explain why the original graph, which we don't see, does not look like this graph. We know the second derivative tells you the concavity of the function. So if I want to prove this function b does not look like this graph, I had to use concavity because second derivative only tell you about the concavity. Now we are going to find the second derivative, and then we're going to check the concavity of the b and see it look like this. So we got dB dt equal to 1/5 times this. So we're going to multiply this out because 1/5 is a number. I'm going to find the second derivative. Derivative number 0, and then 1/5 stay the same, and times b prime, just like the previous question. So I'm going to get negative 1/5 b prime. And then I know I cannot leave it like this. I have to make it entire b. So now I'm going to multiply, because this is b prime, so I'm going to multiply it. Okay, in other words, I'm going to substitute my b prime into here. So I'm going to simplify a little bit. I got negative 1 over 25 and times 100 minus b. This is my second derivative. I found my second derivative equal to negative 1 over 25 times 100 minus b. And I need to use my second derivative to find the concavity of b and make sure the concavity doesn't match this concavity over here. So in order to determine the concavity of the function b, I need to find the point of inflection. So I made my second derivative equal to 0. Okay, so one more time, in order to find the point of inflection, you have to make your second derivative equal to 0 and solve for the possible location. So now over here, 100 minus b equal to 0. Then b had to be 100, because 100 minus 100 equals 0. So b equal to 100 is the location of the point of inflection. Okay, so we have to see. So 0, b equal to 100, and we're going to check the concavity. So we have to use the second derivative to check the concavity. So I'm going to write it over here. So this 100 minus b. Okay, so now I'm going to pick any number between the 0 and 100 and then beyond 100. So I'm going to use b equal to 1, b equal to 101. So I'm going to check. 100 minus 1 is 99. 99 times negative 1 over 25, so it'll be negative. So it's concave down. So 101, so 100 minus 101 will be negative. Negative times negative positive, so it's concave up. So that means the BOT is concave down on the interval b is between 0 and 100, and then is concave up on the interval b is greater than 100. Okay, so it should be concave down and then concave up. Okay, the b equal to 100 is going to be location of the point of inflection. Now let's take a look at the graph. See, we're going to prove it doesn't match. So let's take a look at this graph over here. Okay, so one more time. So when you have a b equal to 100, so we get concave down and then up. Okay, concave down and concave up. All right, so now the point of inflection should be b equal to 100. Let's take a look at this graph over here. Time in days. This is time. Rate in grams. So this is the b of t. 100. If you look at this graph, it already purposely give us the 100. So 100 is right here. Okay. So now you can see the graph does not match. Before the 100, you see that from here? Before the 100, this part, the graph is concave up and then concave down. Okay, so we can say that the given graph shows the concavity that is different from the graph of BOT. The given graph is concave up, then concave down before b equal to 100. BOT should have a point of inflection at b equal to 100. Okay, before b equal to 100, BAT should be only concave down. So the graph does not resemble the graph of BFT. So we finished part B. So it looked like it was not showing half of the, so I'm going to read it one more time. So when we analyze the graph, we say that when b equal to 100, okay, it's up to here, and this graph, it says that it's concave up and then concave down. It changed the concavity before it reached 100. The given graph shows a concavity that is different from the graph of BFT because we already did it. Concave down, concave up, and only changing it b equal to 100. The given graph is concave up, then concave down before b equal to 100. BFT should have a point of reflection at b equal to 100. Before b equal to 100, BFT should only concave down. Should be only, okay, concave down. So the graph does not resemble the graph of BFT. So we finished part B. Now we are going to work on part C. Let's take a look at part C. Part C, we have to use separation of variable to find the y equal BAT. The particular solution to a differential equation with initial constant b is 0 equal 20. So we get dB dt equal to 1/5 over 100. Okay. So 1/5 times 100 minus b, and then b is 0 equal 20. Okay, so we did this question before, if you remember. So now we're going to multiply dt, okay, to the right side. And we do not want to have 100 minus b over here. So we divide it. So this will cancel. So we get 1/5 dt. I'm going to rewrite this over. Now we're going to integrate. On the right side, we get 1/5 times t plus c, because this is dt, so we put t. Over here, we made u equal to 100 minus b, du equal to 0 minus db, du equal to negative db. So we need a negative 1, so we times negative 1 times negative 1. And then we're going to get negative 1 over u times db times negative 1 is du. So now we got negative 1, okay, times, and with absolute value, we want to get rid of the negative 1s. We can divide by negative 1 both sides or times negative 1. So this cancel, you get this. And multiply, you get negative 115 minus c. 2. So we're now going to replace the u by 100 minus b. You can replace earlier if you want to. And then we're going to use e. Just cancel. So we get absolute value 100 minus b. And now we're going to focus on the right side. So you get e to the negative 150 times e to the negative c, because same base, you add this, you go back to this. And then we're going to let k equal to e to the negative c. So we get k times e to the negative 150. Now I go back to my left side. need to get rid of the absolute value, so therefore I'm going to put 100 minus b equal to plus minus k e to the negative 150, and then you minus 100 both sides. Negative b equal to plus minus k e to the negative 150 minus 100. So you have to get b, so divide by negative 1, divide by negative 1, divide by negative 1. So b equal to plus minus minus plus, because switch the sign, and it doesn't matter if you roll plus minus, it's the same thing. And then negative divided by negative to get positive. So we get the general solution. Because p is 0 equal 20, so we substitute 0 and 20. So 20 equal to, we're going to use a positive branch, k times e to the negative 1/5, and then times the time, and then plus 100. Now we can solve for k. So 20 equal to k times e to 0 plus 100, and 20 equal to k plus 100. And then you minus 100, k equal to negative 80. So now your particular solution will be b, and we're using the k positive branch. So okay, so k is negative 80, e to the negative 150 plus 100. So we finished part C.